to understand order of operations, it's really important to start by making a distinction between what is an operator. For example, addition, subtraction, multiplication, and division signs are all operators, but they're not really operations unless you know what you're adding, or what you're subtracting, or what you're multiplying by, or what you're dividing by. So we need to consider operations as one of these signs followed by a number or a variable. So looking at a really simple expression like this one, what we've got here really is a starting number of 10, and then we've got two operations, and the operations here are adding 3 and multiplying by 2. Two different operations. So let's consider, does the order of these operations matter here? Now we can work out whether it matters or not by trying it both ways. So if I start with my 10 and I say, well, let's add 3 first, 10 plus 3, we'll put brackets around it to show we've done it first. 10 plus 3 is 13. And if I multiply 13 by 2, I get 26. But if I did these operations around the other way, I took my 10 and I multiplied by 2 first, that would give me 20. And then when I add the 3, I'm going to get 23. Now, that is not the same answer as when I did it the other way around. So that tells me that the order did matter here. Now, sometimes the order matters and sometimes it doesn't. The way to break it down is to know that adding and subtracting are close friends. They're very similar. They're just the opposite of each other. And multiplying and dividing are close friends. If you're only adding and subtracting, the order doesn't matter. And if you're only multiplying and dividing, the order doesn't matter. But if you're doing one of these and one of those, mixing them up, the order matters. So one way of remembering it, some people like to remember this BIDMAS or BODMAS. I don't especially like it. And the reason I don't like it is it implies that here we've got B for brackets. Well, yes, we do need to do those first. And I is for indices, like powers, something raised to the power of 2, say, or squared. D is for division, and M is for multiplication. I don't like it how the D comes first, because these two can be done in either order. They're equally important. And addition and subtraction are equally important. So this sort of implies that there's a hierarchy here and that one of these comes before the other, and it really doesn't. It would be better to write it as do brackets first, do indices next, and then do multiplication or division, whichever order they come, whichever one comes first, and do addition and subtraction last, whichever one comes first. Okay, now this expression has a little bit of everything in it, so we're going to need to consider what to do first. First thing we need to do is brackets. So we can rewrite all of this, but really just tidy up this section here that has the brackets in it. Now I know that 6 minus 3 is 3. So virtually when I get to here, I'm just going to use 3 instead of that part. I'm not going to rewrite this bit, I can just put it above. All right, the next thing to do is the indices. So here I've got 2 squared, and that means 2 times 2, and that's 4. So again, I might just write that above. I've got 4. Now, let's write this out again so it's nice and tidy. We've got 4 plus 4 times 3 minus 10 divided by 5. And we need to know what to do first. Well, we've done our brackets and our indices, so now we've got to look for multiplication and division and do those first. So, working our way along from left to right, our first multiplication comes here. Now, what is being multiplied by what? Well, it's actually just the 4 that's being multiplied by 3. And if you like, you can put brackets around it, or you could put just a little, maybe just something like this underneath to show that you're going to do that part next. I know that 4 times 3 is 12. Okay, now if I keep moving along, I can look for any multiplication or division, and I've got one here. Now, what's being divided by what? The 10 is being divided by 5. Well, I know that 10 divided by 5 is 2. Now I can rewrite this tidy. I've got 4 plus 12 minus 2. All right, I'm left now just with addition and subtraction, and I can just do those in the order that they come. So 4 plus 12 is 16, minus 2 is 14. I should probably have equal signs on each line here. And that's how I can tidy up something like that, just a little bit at a time. And a nice simple one to finish, just to check that you've got it. Now, lots of adults get this sort of thing wrong. A lot of people just read this from left to right. Start with the 6 and say minus 3, I've got 3. Multiply by 0, I've got, well, 3 times 0 is 0. Add 1 and they'll say the answer is 1. The answer is not 1. How can we tell? Well, we've got minus 3 times 0 and plus 1. They're the three operations. Which one needs to be done first? Multiplication. That always comes first before addition or subtraction. So if we do just this part here first, 3 lots of 0 is 0. So if I rewrite the whole thing, I've got 6 minus 0 plus 1. Now I've just got addition and subtraction. They can be done in any order. I may as well just read from left to right. 6 minus 0, that's 6, plus 1 is 7. So this whole expression actually equals 7. Now let's just double check that it really didn't matter which order we did this addition and subtraction. If we'd done it round the other way, and we had 6 and we added the 1 first, and then we subtracted nothing, well then we'd have 7 minus 0, it's still 7. So you can prove to yourself there that it doesn't matter which way you do those two operations.